All right, here we go for chapter 4. We're going to be dealing with linear functions and their properties. This particular section is relatively simple, actually. It's mostly a review of things that you may already know. Example 1. For each function, first off, we're going to determine the slope of the y-intercept, graph the function using slope and y-intercept, and then determine if it's increasing, decreasing, or constant. Let's start with A. So we have f of x equals 3x plus 5. We have that the slope in this case is the 3, and the y-intercept is the point 0, 5. We can do the coefficient there is, this is in slope-intercept form, and then y-intercept. The graph so 1, 2, 3, 4, 5. 1, 2, 3, and 1. So we are going to start at y-intercept, which is at 5. 1, 2, 3, 4, 5. Then from there, we're going to go up 3 and over 1. So we end up with a nice straight line. And this one is definitely increasing. We know it's increasing because as x is getting larger, y is also different. So we are definitely increasing on this one. Part B. If this here, the slope in this case is -4. The y-intercept is the point 0, 2. Let's go here. Now, start 1, 2, 1, 2, 3, 4. There are two ways to teach negative slopes. And the way that I prefer is starting here at 2. And from there, I'm going to go up 4, 1, 2, 3, 4, and back 1. You could go down 4 into the right 1. You can see we're going to be on the same line if I do that. But I often find that when students have a negative slope, they do negative, negative, and they end up with a positive slope accidentally. So either way is fine as long as you get the correct line. And also, we know negative slopes are decreasing, meaning as x gets bigger, y gets smaller. So this is definitely decreasing. Part C. Y equals 5. The slope in this case is 0. The y-intercept is 0, 5. And 2, 3, 4, 5. And then we have this is called a constant function, which means it is horizontal to the x-axis. Not parallel to the x-axis, horizontal to us. And that makes this, as I just mentioned, a constant function, constant. Just a few properties. Example 2. Suppose f of x is 3x plus 6, g of x is negative x plus 4. Solve each of the following. So let's start with A. F of x equals 0. That means that this is equal to 0. Because f of x is y. So 3x equals negative 6, x equals negative 2. B. F of x is positive, or bigger than or equal to 0, so that's 3x plus 6, bigger than or equal to 0. And we end up with x bigger than or equal to negative 2, right? The steps are the same. And so let's put that in interval notation. That is going to include 2 and go off to infinity. Part C, we're going to set f of x equal to g of x. So I'm going to take f of x here, 3x plus 6, instead of equal to negative x plus 4. Adding an x to both sides, I get 4x and subtracting a 6 to both sides, I get -2, which means x is equal to -2 over 4, which is -1/2. D, f of x is less than g of x, so 3x plus 6 is less than or equal to -x plus 4. And we end up with x is now less than or equal to, again, -1/2. The steps are the same. And I do want to point out I'm dividing by a +4, so I don't switch the inequality. Here it stays less than. So this is going to be -infinity up to -1/2 inclusive. Not too difficult. And let's do an application or problem. I think this is based on a business model of some sort. Oh, this is a cell phone plan. The cost C in dollars of a cellular phone plan is given by the function C of x equals 0.30x plus 7, where x is the number of minutes used. All right, so part A. What is the cost of the plan if you talk for 150 minutes? Basically, they're saying what happens when x equals 150. Let's see what we get. 0.3 times 150 plus 7. $52. So if they talk for 150 minutes based on this plan, it would cost at the end of the month $52. Part B, if the bill is $220, how many minutes were used? Okay, so we're just going to take this and set the whole thing equal to 220. So 0.3x plus 7 equals $220. Subtract a 7. By the way, we know it's going to be more than 150 minutes, right? That only costs $52, so this is going to be quite a bit more. 0.3x equals, what was it? 213. Divided by 0.3. 213 divided by 0.3. 710. 710 minutes. That's a lot of talking on the phone. Part C. What is the maximum number of minutes that can be used for 120? The maximum is going to be 0.3x plus 7 is less than or equal to 120. So subtracting a 7 again, 0.3x is less than or equal to, that's going to be 113. And by dividing by 0.3, let's see what we get. So if we go to the nearest minute, that's 376 minutes. And I know it wasn't exact, but we can't round it up because 377 would exceed $120, and we can't exceed it, so we have to go down to the nearest minute. And like I said, not too bad.